In this video I'm going to show you how to use an LDR with an ESP32 or another microcontroller. First, let's take a look at how an LDR works. An LDR, or light dependent resistor, is a resistor whose value changes depending on the amount of light that hits it. This means that when there's a lot of light, its resistance becomes very low, and when there's almost no light, its resistance becomes very high. So in simple terms, more light means lower resistance and less light means higher resistance. An LDR usually looks like a small round disc, often with a zigzag pattern on the surface. Unlike LEDs or diodes, an LDR is just a resistor, which means it doesn't have a positive or negative side. There's no anode or cathode, so you can connect it either way. To measure light with an ESP32 or another microcontroller, you can't connect the LDR directly. You need to create a voltage divider circuit. Here's how to wire the LDR correctly to your ESP32. Connect one leg of the LDR to 3.3 volts. Connect the other leg of the LDR to a fixed resistor. This creates the voltage divider. Then connect the other end of that resistor to the ground. Finally, connect the middle point between the LDR and the resistor to an analog input pin on the ESP32, or whatever microcontroller you're using. I'm using the ESP32. This way, the ESP32 receives a voltage that changes as the light level changes. Now let's think about what happens. If there's a lot of light, the LDR's resistance is low, which means most of the voltage drops across the fixed resistor. So, the ESP32 sees a higher voltage on its input pin. When it's dark, the LDR's resistance is high, meaning most of the voltage drops across the LDR itself, and the ESP32 reaches a lower voltage. In other words, more light equals a higher voltage at the input. Let's take a closer look at this fixed resistor. What value should this fixed resistor be? That's depending on the type of environment or light range you want to measure. If you use a low value resistor, like 1 kilo-ohm, the voltage divider will be more responsive to bright areas. That means it's more precise in bright light, but less sensitive in darker conditions. If you use a higher value resistor, like 100 kilo-ohms, the circuit becomes more sensitive to low light levels, but less responsive in bright light. So the fixed resistor value depends on the kind of light range you want to measure. In most cases, a good starting point is around 10 kilo-ohms, which you can adjust slightly higher or lower depending on your setup. Now that we understand the schematic, let's take a look at some example code. In this example, I'm using pin 34, which is an input pin on the ESP32. You can use another pin if you like, but make sure it supports analog input. In the loop section of the code, I'm performing an analog read on the LDR pin. This will give a value between 0 and 4095, because the ESP32's analog to digital converter has a 12-bit resolution. That means 0 is the minimum and 4095 is the maximum. However, I don't want to see a number between 0 and 4095. I'd like to see a percentage, which gives me a better idea of how much light the sensor is detecting. To calculate this percentage, I take the raw value, which is between 0 and 4095, divided by the maximum, 4095, and multiply it by 100. This gives me a percentage between 0 and 100. Then I print both the raw value and the percentage to the serial monitor, so I can see exactly what's happening. As you can see in the serial monitor, we're reading values between 0 and 4095 as raw data, and percentages between 0 and 100. For example, if I place my hand over the sensor, both the raw value and the percentage will go down. When I remove my hand, the percentage goes back up because the LDR detects more light again. Now what can we do with this data? We can use the raw value or the percentage to control something. For example, if the raw value is above 2000, turn a light off, and if it's below 2000, turn the light on. Of course, this is just one simple example. There are many more things you can do with an LDR sensor. So, that's a quick overview of how to connect an LDR to an ESP32. It might look simple, but it's important to understand a few basics like the voltage divider and the analog to digital conversion to make it work correctly. I hope this was helpful and thank you for watching.